Hello, this is Geometry, topic 7-1. We're going to talk about isosceles triangles and special segments inside of triangles. Uh, we're going to go ahead and start talking about isosceles triangles. An isosceles triangle is a triangle with two congruent sides. And so we know if a triangle looks like that, we know that it is isosceles. So for example, one, our legs would be AB and AC. Our base would be BC, with the base angles being angle B and angle C, and the vertex angle being angle A. So this is some terminology that you need to know for when we're talking about isosceles triangles. Let's go ahead and go into some postulates and theorems on isosceles triangles. If two sides of a triangle are congruent, then the angles opposite them are also congruent. That means if these two sides are congruent, then these two angles are congruent. Now, if two angles of a triangle are congruent, then the sides opposite them are also congruent. So if these two angles are congruent, then these two sides are congruent. So if AB is congruent to AC, then angle C, because that is opposite angle side AB, is congruent to angle opposite AC would be angle B. And if angle C is congruent to angle B, then the side opposite C, AB, is congruent to the side opposite B, which is AC. So, we know a triangle is isosceles if it's got two sides congruent or if it has two angles congruent. If these angles are congruent, that means that these sides are congruent, which means that this is an isosceles triangle. Let's put this into use. So, here I've got a triangle. I know that the vertex of this isosceles triangle is 30. I know that this is x, and I'm trying to figure out what this is. Well, I know that these sides opposite have to be equal. So I need to figure out what they are. Well, they're 180 degrees in a triangle. Leaves me with 150 degrees for these two. And 150 divided by 2 is 75. I'm going to go ahead and check that. So if I say that this is 75 and this one is 75, 75 plus 75 plus 30 equals 180. So I know that x equals 75. Alright, let's take a look over here. Again, I've got an isosceles triangle. My angles opposite are the same, so this and this are the same, which means that this is 40. If I add those together, I get 80. So 180 minus 80 is 100. X must be 100 because 100 plus 40 equals 180. This is just really quick. I didn't even write an algebraic expression. I just solved these using regular math. Let's go ahead and move on. Now I've got some complex problems. We want to go ahead and set these to be in algebraic expressions. Well, look at these three. Because I know these two angles are the same, I know their opposite sides are the same. Which means that 2x minus 4 equals x plus 5. Subtract x. X minus 4 equals 5. Add 4. And x equals 9. Number 5, we want to figure out what this side is. Okay? Well, this looks like an isosceles with these two the same, but we can tell they're not because they're not the same. Our angles are also not the same. Well, let's see if we can figure something out. Let's see if we can figure out what this angle is. Well, now there's 180 degrees in a triangle. So 62 plus 56, 6, 7, 8, 11, 180 minus the 118 is 62. So this angle is 62 degrees. So if this is 62, that means opposite angles on opposite sides are the same. So x must be the same as 42. And we're done. Now, the only reason I could do this was because this was isosceles. Had this turned out to not be isosceles, I would have had to go into sine, cosine, and tangent, which we probably have not covered yet this year. So, let's go ahead and move on. We are done talking about isosceles for a little bit. Let's go ahead and talk about some terms. Well, an angle is a bisector is any angle that cuts a ray into two congruent angles. So that's our angle bisector. It cuts it in half. Well, now we're talking about an altitude. An altitude is a perpendicular segment from any vertex to its opposite side. I'm actually going to use a pen. I've already got my triangle drawn. If I go from a vertex, hit the opposite side at a right angle, then I have an altitude. This is one altitude. I actually have several altitudes. I have another altitude. That forms a right angle from that side. And I've got another altitude that goes from this angle and comes in and hits at a right angle. So there are three altitudes for every shape. Next, I have a median. The median is from a vertex to the midpoint. So this is halfway. That's one median. This is halfway. So that's another median. And that's halfway. So that's our third median. Okay, medians cut the opposite side in half. Okay. Next we have our perpendicular bisector. It is a segment that is perpendicular to a side at the midpoint. So we come over here to the midpoint and make a right angle. We do that with all of our sides. We come over here, find our midpoint. Make a right angle. Come over here, find our midpoint. And we make a right angle. So, our altitudes go from a vertex, make a right angle. Our medians go from a vertex and go to the middle. And perpendicular bisectors start at the middle and are perpendicular. They make a right angle. So, these three terms are different. They mean different things. Occasionally, we'll get a circle where an altitude is a median and the perpendicular bisector. And so we may have some triangles where one line is several of these, but they each have their own definitions that you need to make sure that you learn. So let's go ahead and move on. An example. BG is the median. Median means that it cuts this side in half. So BG is 4x plus 10. AG is 6x plus 4. And CG, 7x minus 5. Well, I know that these two are the same because it's a median. So 6x plus 4 equals 7x minus 5. I'm going to go ahead and start by subtracting 6x. Get that 4 equals x minus 5. Add 5. And 9 equals x. So, we use the definition of a median to know that this was in the middle, and we could solve. Moving on. Okay. Given that AF is an altitude, altitude means that it hits the side at right angles. And it says the measure of angle 1 is 8x plus 18. We know because of the altitude this is a right angle. So 8x plus 18 equals 90. We subtract 18. 8x equals 72. Divide by 8. And x happens to equal 9 again. Alright. Let's go ahead and talk about the isosceles triangle. So now we're talking back about isosceles. This is the special case. Okay, AD is an angle bisector and an altitude and a median and a perpendicular bisector. This is true for all isosceles triangles. So, let's go see if we can figure things out. Two angles that are equal would be angles B and C. Or, that's because of the isosceles, but what's marked is that BAD equals CAD. Perpendicular lines would be AD with BC. And perpendicular pieces would be BD and DC. And so for an isosceles triangle, all of these markings are always true, as long as it's from the vertex angle. Okay? If this is from the vertex, then this line is an angle bisector, an altitude, a median, and a perpendicular bisector. Not so much from these two. These two are totally different, but this line segment in particular happens to have all the qualities. So let's go ahead and take a look at this. An isosceles triangle ABC below, BD is an angle bisector. Means it cuts the angle in half. Find the values of x, y, and z if the measure of angle 1 is 6x plus 7. We're going to call this one 1 and this one 2. 2, 3x plus 16. Measure of angle 3 I guess we'll call this one 3. Is 3y minus 1. AD is 2z plus 1. And DC is 2z minus 5. So, I know that 1 and 2 are the same because it is an angle bisector. So that means that 6x plus 7 equals 3x plus 16. Subtract 3x from both sides. We get that 3x plus 7 equals 16. Subtract 7, 3x equals 9. Divide by 3 and x equals 3. Well, that's one piece of information. Now let's see if we can find out what y is. Well, y is down here. Well, in order to know what's down here, I've got to figure out what these angles are. So let's figure out the vertex angle first. If I do 6 times 3 plus 7, 6 times 3 plus 7, we get 25. So that means the angle 1 is 25, which means the angle 2 is 25, which means that my vertex is 50. So we figure out what these sides are. 180 minus 50 is 130. So both of these together are 130. Because it tells me this is isosceles, I know that these two are the same. So I take 130, divide by 2. I get that 65 is a measure of these angles. So this one is 65 degrees. So 3y minus 1 equals 65. Add 1. 3y equals 66. Which means that y equals 22. Now, because I know this is isosceles, and I know this is an angle bisector, I know that these two pieces also have to be the same. Going back to up here, my picture. So if I know these two are the same, then I know that 2z plus 1 equals 5z minus 8. Subtract 2z. 1 equals 3z minus 8. Add 8. 9 equals 3z. So z equals 3. So I know that x is 3, y is 22, and z is 3. So, if you need to rewind this and watch parts of it again, please feel free to do so, especially if you are weak on understanding these terms right here. Hope you have a good afternoon, and good luck on your assignment.